Hello everybody and welcome to a new video in the Generative Music AI course. In the previous video we saw different generative techniques that we can use to create music with algorithms. Today we're going to look at limitations of current generative systems, and we're going to also look at different strategies we can use to overcome such limitation. Here's a menu for today's lecture. We're going to look at the limitations of state-of-the-art systems. Then we're going to look at limitations in the overall research procedure in generative music, and I'm also going to outline new directions that we can take. First, I want to bring up a type of generative music system that's quite trendy right now. We've encountered it already quite a few times in previous videos, and that's the text-to-music model, like for example MusicLM or MusicGen. So these models have quite a lot of shortcomings. One is that they tend to struggle quite a lot with long-term structure, that is musical coherence on a large scale. And the reason for that is because these systems have quite a hard time learning long-term dependencies. One of the other issues that we have here is that of audio fidelity, which basically means that the quality of the audio rendering that we have there is definitely not at par with the quality of audio production that we can have when a professional works on a piece of music. Now, this particular issue has been somewhat addressed with the latest models like MusicGen, but still we're not at that level yet, at that professional level. Another issue that's quite intrinsic to text-to-music models is that of semantic mapping. This is inherent to music. What do I mean by that? Well, there's a huge issue in finding a good mapping between words and music, and the reason is because there's no objective one-to-one mapping between the two. In other words, let's say I think of progressive rock or classical music. My idea of progressive rock or classical music is going to be different than your idea of progressive rock and classical music. In other words, if we were to describe a piece of music with words, we would come up with different words, with different descriptions. And this is an issue because the moment you only have a textual interface with a model in order to steer the generation of that model, having something that's quite subjective like description of music with words could be a problem. Another issue that comes with text-to-music models is that of minimal creative control. At the end of the day, all you have is an initial description that you can give to that model, and if that doesn't work, then you'll just have to give another description and start from scratch. And even there isn't really a lot of tweaking that you can do. So the amount of creative control that you have with these models is quite minimal, which basically means that these models are good, they're quite okay for amateur musicians or people on social media who just want to have a track super quick, but for professionals this is not necessarily a great interface or a great model. I want to abstract out from this particular model and look at an overall trend right now in generative music, and that is the fact that generative music researchers tend to focus their research onto deep learning. They've basically completely ignored the last 50 years of research in generative music, mainly connected with this idea of musical knowledge, music theory. And basically what they do is what I call the curse of deep learning. The curse of deep learning applies to a lot of different fields, not only music, but it's quite relevant here in generative music as well. And the curse of deep learning goes like this. So I'll get all the data for a particular problem that I have or task that I want to solve, and I'll just throw all of them at a deep learning model without any information about that particular domain, completely ignoring all the domain knowledge. Hopefully that model will learn what it has to learn, and then everything will work honky-dory. Now, sometimes this approach can work, other times it just doesn't. In generative music, in my opinion, it doesn't work. It can work for certain tasks, but not in general. Deep learning is not the silver bullet for generative music. it comes with a lot of problems, and we'll see some of them here. We need to reflect on music at large before we get into problems associated with generating music with deep learning. Music is highly dimensional. What do I mean by that? Well, I mean that there are many factors that determine music: harmony, melody, rhythm, structure, performance, production. These are all different levels that are combined together in order to create what we call music. They make up music. The problem is that they tend to have a very, very high dimensionality, and with a neural network, it is very difficult to extract all of that knowledge or reconstruct all of that knowledge directly from data. And the reason why that's the case is because normally a deep learning model doesn't know anything about music knowledge. So it's going to be way more difficult for a neural network to extract that information from scratch, rather than having another model that already knows a little bit about different musical aspects, like say key, harmony, tempo, this kind of stuff. Another issue that we have with deep learning models is that they use massive data sets. You need to have a lot of data in order for these models to create like these abstractions and learn from data. And what this also entails is that you need to have a lot of computation, GPU computation, to train these models. As we saw in the case of text-to-music systems, deep learning models in general tend to have quite a hard time having a high-level musical coherence. They tend to be quite good at creating music at a small scale, at the level of a bar or a short phrase, but then the moment you move up to a larger musical structure, like for example an overall section or even a piece of music, at that point it becomes like very difficult for these models to create something that's coherent. The result usually is sort of musical random walk in the music space. Finally, a major issue that I have with deep learning models for generative music is that they are black boxes. We really don't know how they work, and for that reason it is particularly difficult to steer them in a creative direction that's aligned with what we have in mind. I have a fantastic visual representation of that with this GIF, and indeed I do believe that these models are as powerful as rally cars. They are powerhouses. The problem is that they're really, really wild and difficult to control. Yann LeCun, one of the fathers of deep learning, arrived at something similar in the case of general intelligence. He wrote this tweet this year saying, on the highway towards human-level AI, large language model is an off-ramp. Large language models are transformer architectures. It's an architecture used in deep learning. Yann LeCun expanded this idea in a position paper that I highly suggest you to read. It's called A Path Towards Autonomous Machine Intelligence. What he argues here is that these models, deep learning models just by themselves, are super wild and they tend to be reactive. What does that mean? It means that they just like react based off of some signal that they receive. In the case of a large language model like ChatGPT, they receive as input a sequence of characters, of tokens, and then they generate the next token in a probabilistic manner. They don't have any structure at all. They don't do any reasoning. They don't manipulate symbols in order to reason on a high level. And they don't have a structured representation of what they operate on. And that is a shortcoming, because in order for reasoning to happen, you need to have more structure. In this paper, LeCun suggests an architecture where deep learning is used in conjunction with other methodologies in order to arrive at a general type of machine intelligence. Of course, in our case, we're not talking about general intelligence at large, but rather a narrow type of intelligence that's that of musical creativity, the ability for machines to generate music. But I do believe that the same principles apply also in our specific field. In order to solve the curse of deep learning, I suggest we try to implement hybrid systems. And what that means is basically having systems that use multiple techniques. In particular, I suggest to merge deep learning with some symbolic AI. This is nothing new. This has been done for quite some time, and the overall field that tries to do this beyond music, in other fields as well, is called neuro-symbolic integration. By merging these different techniques, we can achieve something cool. That is, we're going to have the wilderness, the power, the generative power of deep learning, but then at the same time we're going to have musical knowledge that comes from symbolic AI. Indeed, the ultimate goal is that of orientating the wilderness of generative deep learning models with reasoning on music knowledge. This is another visual analogy that expresses like what I have in mind here. So you have these wild horses and they are the neural nets, and then you have the person who sort of controls the wild horses there, and that is symbolic AI. This is a line of research I've been experimenting for quite some time, working on these generative music systems that are composites, where symbolic AI is put on top of raw generation that happens at the level of neural networks or deep learning models. Music representation is another big problem in generative music right now. Indeed, the different representations that we have as of now are not that great. Audio tends to be too complex and it doesn't have a lot of information about compositional stuff that are super interesting, like key, tempo, harmony. You have to learn all of that directly from the sound itself, hoping that a deep learning model is going to be capable of doing that. By contrast, in the case of symbolic representations, these tend to be too simple. They oversimplify music. They have a lot of information about the compositional aspects, but they completely ignore all the production nuances and performance nuances. Indeed, we don't have a representation that's able to capture all the necessary music details efficiently. And by efficiently, I mean that it is compact and we can manipulate it as much as we want with our algorithm. Another issue connected to music representation and generation that I've seen lately is this new trend where all the generative music researchers are going after audio models, completely ignoring or almost completely ignoring the symbolic representation domain. That's an issue because I believe that symbolic is able to provide a lot of value in terms of musical information to the generative models that we want to develop, whereas audio could be a dead end, not necessarily for all tasks in generative music out there, but for particular tasks, especially when we want a musician in the loop. So for tasks that are addressing more professional users. My suggestion here is once again to go for a hybrid approach, finding a representation that's able to encapsulate elements of the symbolic domain as well as the audio domain. As an example, we could build embeddings which encapsulate information that comes from different domains, symbolic, audio, and also contextual information about high-level metadata, like for example the genre of a certain piece or the overall emotion. Most importantly, I suggest that we push quite a lot onto custom representations. This comes from my experience in generative music. The best models that I've built are the ones where I created custom representations that were ideal for the particular task that I had at hand. Another major issue that's almost completely overlooked in generative music is user interfaces. When's the last time that you read a generative music paper and there was a user interface associated with a model? Probably never. Yeah, and that's a problem. And the reason is because user interfaces are as important to a generative music system as the model itself is. And the reason is because at the end of the day, we want users to use our models. So the code, the core model is extremely important, but it is as important to have an interface that works well for that particular user that we have in mind. Indeed, in order to reverse this situation, what we should do is taking a user-centered way of creating these models, so that for each model we have an associated user interface that works well with that particular user for that particular task. Another thing that we can do to go in this direction is to have user evaluations of the user interface that we have. So whenever we build a new model, we attach a user interface on top of it, and then we evaluate that interface directly with users. So far, we've addressed the limitations attached to the generative models themselves, but there are also huge problems in the overall research venture in generative music. First of all, the main issue that I see here is that currently generative music is dominated by large, big companies. And the problem with that is not ideological, it's very practical, is that when they release a new model, they rarely release the code associated with that model, and they almost never release the model weights. And there's a problem with that, and the problem is that the overall package is not reproducible. Lately, we faced a new problem with novel generative music models. These models tend to be quite complex. Take MusicLM as an example. It's made up of many neural networks that are embedded within each other, and the problem there is that each of these networks oftentimes is a proprietary neural network, is a proprietary model. So this makes things ever more opaque and less transparent, because not only we don't have the code and the model weights like for the whole model, now we don't have code and model weights for the embedded model within the overall model. Another major issue that I see with generative music research is that the space for smaller institutions to innovate is shrinking day after day. When I talk about smaller institutions, I refer to academic research labs as well as smaller startup companies. We're witnessing something that's happening not just in the generative music space, but in AI at large. There are a few large incumbent companies. We're talking about the Googles of the world, the OpenAIs of the world, that basically dominate generative music innovation at large. The risk is that in a matter of a few years, we're going to get in a space of an AI oligopoly. Let's see how we can counter some of these issues. First, I suggest we foster open source as much as we can. We want open source code, models, model weights, as well as datasets. Next, I suggest we don't allow people to publish papers that are not reproducible. What I mean by that is that whenever we have a paper that demonstrates a new generative music model, these papers must have available code and available model weights. In 2023, this is not a really high bar, and I believe that all the articles published in the generative music field should comply, should be reproducible. Small institutions can fight back tech giants on a quantitative level. They have to bring the battle on a qualitative level. What I suggest they do is to focus on small models. Most of the time, smart in AI is way better than big. If you have a small model that's very well crafted, most of the time this model can perform better on a particular task than a huge model that's very generalist. What I suggest in order to come up with these small models that are way more manageable in terms of data and in terms of computation is to use a lot of techniques, like for example, knowledge distillation, model pruning and others, in order to reduce the dimensionality of these models. At the same time, I suggest we follow a particular machine learning philosophy that's called data-centric machine learning or deep learning. This has been proposed by the famous machine learning researcher Andrew Ng, basically the focus here is no longer on the model architectures, but rather on data quality. It is preferable to spend a lot of time on data and having a great data set rather than spending a lot of time and energies on the architecture itself. Another major issue that I see in generative music research is a complete division between engineers, researchers, technologists, and creatives, composers, and music theorists. This reminds me of the beginning of the history of generative music research. Today we're just getting back there, and the reason is, once again, deep learning and the curse of deep learning. Given researchers believe that they can completely ignore musical knowledge, then there's no reason to have conversations with the other side of the moon, that is, creatives, musicians, and music theorists. This is a huge problem, and it's going to literally impede innovation in generative music in the longer run. What I suggest here is to bridge the gap between the technical side and the musical side. So we should have teams that are highly interdisciplinary. And indeed, this is what we are trying to do here with the Generative Music AI course and the workshop that we'll have in Barcelona. The basic idea is to bring together around the same table people with different set of skills in order to advance research in generative music. Let's wrap up this lecture by looking at the main points we covered. First, don't fall for the curse of deep learning. Don't think that you can use deep learning completely ignoring everything about music knowledge and music theory. Remember that deep learning models have a lot of issues currently. Some of them are audio fidelity, the problem of musical coherence, and the fact that these models are very difficult to steer in one specific creative direction because they are black boxes. To counter this issue, you can try to develop hybrid systems that merge together deep learning with more traditional techniques. We still have major issues with music representation. There are limitations about symbolic representation of music and audio representation of music. We should try to merge those two together in order to find more efficient representations of music. 99% of the attention in generative music goes to the models, to the systems, to the core generative side of it, but there's very little work on user interfaces, and here there's a ton to innovate, and probably there will be a lot of products that will succeed not because of their generative models, but rather because of their new and innovative user interfaces that are very targeted at a specific user. With the renovated interest of big tech companies in generative music, we run the risk of having a big tech oligopoly in generative music research. This is a major issue, and in order to counter that, we should try to push as much as we can towards an open source world in generative music, and for smaller institutions, they should focus on small models using intelligent strategies to fight back against big tech. Last but not least, we've seen that right now we're at a point where there's still a huge divide between engineers, researchers, technologists on the one hand, and creatives and music theorists on the other. This is not a good way of advancing research in generative music. What we should do is try to bridge the gap. Congrats! You're not only at the end of this lecture, but you've actually completed the first part of the Generative Music AI course, that is Foundations. We've covered a lot of terrain. Next, we're going to dive deeper into the technical aspects of generative music. That part will be mainly addressed at engineers, but I'm going to try to be transparent enough so that also musicians will be able to follow most of the information. Before I dash off, I just want to remind you about the workshop that will take place in Barcelona at University Pompeu Fabra. If you're watching the video when I'm publishing it, I just want to remind you that registration will open next week on Monday, the 13th of 2023. This is the event website. You have all the necessary information here and you can also register. Again, registration will open on November the 13th. There are only 30 spots available for the workshop, 20 for technologists and 10 for musicians. If you are interested in attending, hurry up. That's all for today. Thank you very much for your attention. I'll see you next time with part 2 of the course. Bye bye.